Okay, today we are learning adding and subtracting mixed numbers. So I'm writing that right here. Adding and subtracting. Right now we're going to practice adding. Then we'll do mixed or subtracting after that. Okay? The story problem says Raquel measures milk with a half cup measuring cup, and she fills the cup 5 times. So she has 1/2 of a cup, and I'll draw a little cup here. And she has it's half full, so this is a half. Okay, and she's going to do that 5 times. Okay, so times 5. All right, now I need to figure out how to do that. So the simplest way I can see how to do it, because it's not asking me to do it very many times, I'm going to add the fraction 5 times. That's one way I could solve. 1, 2, 3, 4, 5 times. Okay? And we already know about adding fractions. What stays the same, Bridger? When I'm adding fractions, what stays the same no matter what, anytime?
The bottom, the 2.
The denominator never changes, right? There's always a half of a cup. And the denominator, I like to say, stands for the serving. There's always a half of a cup of serving available. So 1/2 of this is available for us to partake, eat, drink. Okay, so the denominator stays the same. Then I add straight across. 1, 2, 3, 4, 5. 5 over 2 is what it equals. It's equivalent to. What is this fraction called right here, Tavy? Improper fraction. So improper means the numerator is greater than the denominator. Let's change that into a mixed number now because we're learning about mixed numbers. Okay? All right. So one way we can do that is drawing a number line. And what is equivalent to 1 when I'm talking about this fraction right here? 1 whole is equal to what fraction, Hannah?
2 over 2.
2 over 2. Okay? All right, so I'll draw a 1 right here. 1 whole, so 1 whole cup, which is equal to 2 over 2. And I have to count backwards, so 1 goes, or let's start, it goes to 2, so 2, 1, 0. So this would be 1/2, and this is a 1. I'm going to make it look like the number 1, okay? And then I need to go out past this. So remember, these are all serving sizes. So I have a portion right here, a serving size there, and a serving size there, and I have to have a total of 5. So I need to go 1 and put a tick, 2 and a tick, and 3 and another mark, and then I'm done. So I have 1, 2, 3, 4, 5. I'll write that in pink. 5. Okay? All over 2. So now I have to label these so they make sense to me. So I go 1, 2, 3, 4, 5, and make them all into fractions. Okay, and I'll erase this so it's not confusing you. Do you see the answer? And can you see it also on the number line, Aspen?
Yes.
It's right there. I can see it there. I can see it there. Okay? All right, so that's one way I could solve and make sure I did it correctly. The other way I could solve is take this 5. How do I make 1/5 into a fraction? So 5 wholes. So 5 entire cups. 5 entire half cups, I meant. How do I make it into a fraction, Danica? It's not showing, but it's just sitting right there like that. Can you see that? Every whole can be made into a fraction just by adding a 1 underneath it. So I can also take this 5 and make it into a fraction. And when I'm multiplying across, I go 1 times 5 is 5, 2 times 1 is 2. Does that match? Can we see that this one matches this one, matches this one, right? Because remember with math, there's all kinds of ways I can solve the exact same problem. Okay, there's one other way I'm going to show you how to solve this problem. And we'll move some of these out of the way. Some little ties. Okay, if I have 5 over 2, let's erase this. 5 over 2. And another thing I can do is go 2 divided by, 5 divided by 2. What I'm thinking to say. Okay, now this is simple division, right? Jackson, how many times will 2 go into 5? 2 times. And let's skip count. 2, my class. 2, 4, 6, 8. Stop. I can see that 5 is somewhere here, and this is 1. That's 2. So 2. And 2 times 2 is 4. And I take the difference away, and I get remainder 1. Okay? And when I have this information here and this information, this is something you have to get really good at, is transferring this information into a mixed number. So I have the answer 2, and I have remainder 1, and the denominator is always this 2 right here. So 2 1/2 is a mixed number, okay? So this is where I got the answer for mixed number. Right here it's an improper fraction. I have to transfer it into a mixed number, okay? So, on your sheet of paper in your workbook, find a little spot, and we're going to practice transferring an improper fraction into a mixed number a couple of times, okay? So find a little spot, yep, where you haven't written very large, and let's go 9 fourths. So this one doesn't have anything to do with your workbook. We're just practicing improper to mixed numbers, okay? All right, how did I do that again? Kyan, do you remember the step? I divided 9 by the denominator. Can you see that? See where I got that information? Okay, and let's keep count by 4s. 4, class? 8, 12, 16. Stop. And I have to see where the 9 lies. It lies somewhere here. So I will say this is once, twice. I want to make sure you don't think that that is a multiplication. So 1, 2. So 4 times 2 is 8. I take away the difference, and I get, it has to be less than 4. That means I'm done. Remainder 1. Okay? All right. I'm going to write this 2 in pink, and I'm going to write the remainder in purple. All right, now when I transfer those over to mixed numbers, it'll make more sense. So anytime I have one whole, that is my whole in a mixed number. My remainder always goes in the numerator column, and the denominator always is this 4. You see that? You see where the 2 came from, the 1 came from, and the 2? 2, 1, and 4. Okay, let's try it again. Let's do 12 thirds. Ooh, you might not get a mixed number on that one. What's the first step, Gabe? How do I set it up?
We put, let's see, 3 is divisible by 12.
3 into 12? And how many times 3 go into 12, Heath?
4.
4. Do I have 3 times 4 is 12? I take away, I get no remainder. And I transfer it, and I put the pink is the whole number. So this 4. And I would put the remainder here, and the denominator would be this 3. 3 there. Do I leave it like that? That means nothing, right? This fraction means absolutely nothing. So I would just put